Hello everyone and welcome to Natural Ingredients 101, Master Moisture in Dried Fruits and Nuts, presented by Zachary Cartwright and Mary Galloway. Today's presentation will be about 30 minutes, followed by about 10 minutes of Q&A. If you have a question for Mary or Zachary, type it into the questions pane at any time during the webinar, and we'll be keeping track of these to answer during the Q&A. So please don't be shy and submit those questions. We'll also be sending out a link to the on-demand webinar as well as the slides for you to review as soon as they're available. So without further ado, I'll hand the microphone to Dr. Zachary Cartwright.
All right, welcome to Natural Ingredients 101, where we'll be talking about dried fruits and nuts. So whether you're using these as final products or maybe as ingredients, we're here to talk about how you can control and monitor the water in these types of products. So first, we're going to simply talk about the variability that exists in dried fruits and nuts. So we're going to bring up an image here, starting with fruit. And it basically looks like a scatter plot showing the relationship between water activity on your x-axis and moisture content on your y. So this is some of the data that Mary collected. So I'll hand this to you, Mary, and maybe you can talk about what we're looking at here.
Right, so there is a lot of variability within different types of fruit, but there's quite a bit of variety within one type of fruit, and we're going to pull out the data for blueberries. So we're going to kind of focus on blueberries and almonds in this webinar so that you can we'll just focus on talking about those two things and using those as our examples. So some of the variability you're going to see in the fruit has to do with the sugar and fiber content that you're going to find in the fruit, and that could be from various things. It could be within the different kinds of fruit. So I'm going to throw another example, like mangoes are very fibrous fruit, and you get a really different relationship there. We've got a lot of variability within water activity and moisture content for that. For the blueberries has more of a trend, so that's where we wanted to kind of show that there is more of a predictable relationship between water activity and moisture content. But even at that, you're going to get the differences in the sugar and fiber content even in a blueberry. Varietal differences are going to play an impact. So what variety of blueberry are you going to have and how that impacts those things. And then also drying method. So, you know, how that is processed. Are they processed as a natural, non-sweetened blueberry? Is there sugar added or whatever that might be? And also I wanted to put out there too that this can be a difference in how the growing season goes, right? So even if you have exactly the same grower, the same variety year after year, you can have differences because of the growing season on how that has impacted your sugar and fiber content too. So all of that plays a role in the water activity and moisture content in the food that you're either supplying or importing, right? So where do those impacts come? So you're going to see those varieties in the water activity, like I mentioned, especially for moisture content, you're going to see that impacted in yield. So if you're selling by weight, that's going to impact, if you're only measuring the moisture content, that's really going to affect the yield that you're going to be getting out of, your crop that year. Another factor that you're going to see differences between fruit is pH. And the reason I mention that is the fruit tends to be acidic, which means it has a low pH, but that means it's more acidic. And when you have something that has more acidity, you can actually get away with a little bit higher water activity, so you don't have as much trouble, you could say, with maybe mold limits or whatever. So if you have a fruit that's higher this year that has a higher pH, and you're like, okay, we're going to produce a bar or a snack at this specific water activity limit, maybe the next year it has a lower pH, and now you don't kind of have that buffer. So pH really does impact fruit in particular, but also anything that would have pH as a factor for it, right? So gummy production or something like that. As we mentioned before, yield is a factor. And also, what are you going to be doing with your fruit? Is it a snack versus an ingredient? Maybe you're going to have different criteria in that fruit.
And I'm glad you brought up growing season as well, because I know that I've worked with a lot of companies, and even though they're always producing dried cherries or the same product year after year after year, it can still vary by growing season, and that makes measuring moisture a challenge, even from year to year. What about nuts? What type of variability do you see with nuts, more or less, or is it a similar
Yeah.
scatter plot that we're going to look at?
A little bit of a scatter plot, not as much. We have a graphic here where we're showing a variety of nuts. So it was a similar study that we did. So we have a lot of different kind of nuts, almonds, peanuts, cashews, and you can kind of see it is a little crazy. And we pulled out almonds specifically, and you can see that there's a pretty nice trend with almonds, but it's different than the blueberries, and we're in a much lower water activity range. So you don't see as much variability. You still do for similar reasons, right? But even to add beyond like growing season and that kind of stuff, it could also be the way the nut is produced. Is it raw? Is it dried? Is it salted? Is it, has some flavoring? Those are all impact the water activity and moisture content of a nut. Also, something to consider is that nuts do live in a lower water activity range, and when they are low, they can be susceptible to rancidity. And we've talked about that in other webinars and things. So basically, when you have low water activity, it's able to be exposed to the environment and oxidize more. So that's a consideration for growers and for importers when you're looking at a nut. We can use the isotherm relationship. You can see it's really nice with the almond that it's tracks really nicely. You can see a definite relationship between the water activity and moisture content. So almond's relationship with moisture is pretty, you can determine that relationship with the isotherm, which we're going to talk about a little bit more. And same thing, you have to kind of consider what you're going to use your nut for and in what form too, right? So we have less variability, which is great. But are we using it as a snack? Are we using it as an ingredient? Is it whole, salted? Is it a paste? Is it just pieces, right? So those all kind of impact that relationship too, in the sense that, how easy it is to change water activity and moisture content for the nuts.
So just to kind of summarize this first part, I think what we're trying to demonstrate here is that there's a lot of variability, whether it's fruit or nuts. We've shown these two scatter plots, and we're going to focus the next sections on looking at blueberries and almonds. We're going to talk a little bit about the implications of having variability, how to reduce variability, and then we'll move into isotherms and finish with what happens when we mix these things together.
Right.
Now we're going to talk about some of the implications of variability, and we're going to start with the obvious, looking at texture and taste. And Mary has gone ahead and set up a small experiment for us. So I'm going to let you describe what we have here in front of us.
Yeah, so we took two different kind of conditions to kind of help demonstrate where it's going to be different if we have a kind of overhydrated or a hydrated, let's say, product for fruit and nut here, our blueberries and our almonds, versus something that's been dried down a bit. So if we take these blueberries here and these almonds, we've put them at a higher water activity. So they're probably living around 0.7. And for a blueberry, I know it's a little hard to see on the video, it's a little soft. There's a really soft texture to it, which is not terrible for a blueberry, although you do want to be careful because there is that mold limit at 0.7. And even with that pH that I talked about, kind of would recommend not really getting too close to that zone. So here it's like the texture is soft. If you were just eating these plain by themselves, you might like it okay, as long as they weren't moldy. But for the almond, it's going to be different. This is going to be too moist, too high water activity for the almond, and it's going to be soft. And as you can probably imagine what it's like to bite into a soft nut. I'm sure, even if I'm pushing on, I can feel it give a bit, and you know what that's like, right? Everybody knows what that's like. In comparison to the more moist samples here of blueberries and almonds, we've got here dried almonds and blueberries. And for the almond, that's kind of a natural place for the almond to be, is at a lower water activity. And so when you bite that, you get the nice crunch. You expect it to be a nice crunch. But for the blueberries, it's hard. That is not a happy place for the blueberries to live. And, as we were talking about the example, when you bite into a soft nut and you don't like that, you're probably bitten into a hard fruit and you don't like that either. And if I was to just kind of rattle these around, because I know it's difficult on the video to kind of visualize a little bit, it's you know,
Yeah, you
noisy.
can hear the difference.
You
Yeah,
can hear that
definitely.
these are dried out, right? So when we're looking at trying to find a balance between water activity and moisture content, you need to kind of consider what that's going to be doing to your ingredients. Are we going too low and we're getting, too hard texture, or are we going too high in water activity and getting a soft texture? And how to find the balance between the two.
And I just want to ask you a little bit about how you set this experiment up. How did you determine what water activities to equilibrate to, and where do those numbers come from?
Yeah, so mostly we look at kind of the native water activity of our ingredients, and we do have some examples where we've taken these as they are kind of naturally and blended them, so you could see where are these going to, if we didn't do anything to them, if we just took them straight from a supplier and blended them, where are they going to end up? So we kind of start where they natively begin and go from there. And there are definite reasons why, and some challenges when we have the low water activity, like for the nuts, about the rancidity. You don't want to stay away from that. But mostly we just stayed kind of in their natural areas and then flip them. So where the low water activity for the almonds, we put the blueberries down there, and vice versa for the upper, for a more of a moist blueberry, and to see what it was going to do with the almonds.
And I think this also goes back to our first section where we talked about, are you going to use this as an ingredient or a final product? Because you might want a drier blueberry in a cereal or something like that. So, but if you're snacking on the blueberry, then you definitely want something softer. So just thinking about how these are going to be used will help you to set your target. From here, let's go and talk a little bit about accounting for variability and maybe improving the measurements. And then we'll talk about how to mix these things together.
All right.
Next, we're going to talk about measuring and accounting for variability in fruits and nuts. And Mary, I'd like to ask you, how is this done now? How do people measure moisture in fruits and nuts?
Yeah, mostly it's a moisture content value that they're getting. Both of these industries have been around a long time, and so they kind of have some archaic ways to determine moisture content. And so we're looking at, a loss on drying was normally how we do it, or sometimes they'll do a moisture balance, where it's basically you're getting a faster moisture content, but you have a really hot lamp that is going to, try to drive off the moisture. The problem being that both of these have, they have issues with being at high temperature. Fruit has high sugar, you can get browning and some hydrocarbon conversion there, and the nuts can toast, so those kind of throw off moisture content. The fruit industry actually also has some other ways, kind of older ways, where they're basically measuring a change in electroconductivity of a fruit paste. It's kind of not maybe the most accurate way to do it, but it's traditional, and when you have traditional data, it's hard to pull away from using that measurement when that's like where all your historical data has come from in the past. So, but I think this might be a really great transition to talk about the relationship between moisture content and water activity and why that's important. And so if you want to take some time and discuss what that relationship is and how we can measure that and what the implications are.
Yeah, so in the past sections, we've mentioned water activity quite a few times. And the reason for that is water activity is a much easier and more precise way to think about the water in your product and how it directly relates to quality or even safety. And so what we're going to show here is an image that shows the relationship between water activity on your x-axis and moisture content on your y. We showed this earlier when we showed those scatter plots, but I think looking at this a little bit closer will help to understand how this relationship can be used, especially as we talk about mixing in one of our next sections. So if we were to map the entire relationship between water activity and moisture content at a specific temperature, then we get this entire moisture map that we call a moisture sorption isotherm. And we have a really unique way to do this at Meter Group. We have a method called the dynamic dew point isotherm. And basically what this allows us to do is create a really high resolution isotherm so that we can see that entire relationship. And the one way that this is really useful is that as you move up and down this curve, it can help us to understand things like reaction rates. So you mentioned it earlier, things like lipid oxidation will occur at certain water activities. So if we use this moisture map, then we can set the right target for our almonds, maybe around 0.3 water activity. There are also browning reactions or enzyme activity, other things that can happen as we move along this curve. We can also use the isotherm to predict when microbial challenges may present themselves. So whether it's a mold or bacteria or yeast, these things are going to start to occur as we go up in water activity, and that's something that you can keep in mind when you look at this isotherm curve. And then the last thing to keep in mind are texture changes. So if we were talking about a powder, it might be a caking and clumping point. Even here where we're talking about texture, these texture changes may show up on our isotherm curve and may be something that we can identify what we call a critical water activity, so we know the range of water activity that we need to stay within before we start to have noticeable changes. So the reason I bring up this curve is because it's a really good way to think about all of these different things affecting the safety and the quality of the product that we're looking at. And that isotherm is going to be specific to each of the products or each of the ingredients that we look at. Is there anything that I'm missing, anything else that you would add about using isotherms?
No, I think you've done a really good job, and hopefully you'll be able to visualize, as Zach was talking there, about the different influences that water activity can have on a product, because it does, as we increase water activity, different changes can happen. There's different modes that are happening within there, so some of them may make perfect sense, but like the browning reaction where it peaks, it has to do with the water that's in the surrounding area of something. So there's different, it's like switching different modes as we're moving up in water activity, but that all has an impact on a product that's physics and you need to be aware of.
So let's say that we have an isotherm now. How can that isotherm be used to improve precision, especially if you think of, I believe we have an example with a pecan. Yeah. So maybe you can walk through that example and talk about how having variation in your moisture content measurement is going to show up on the isotherm curve.
Right. This is where, precision in the measurement really matters, because if we're using kind of an older traditional way, and this was a real life example with pecan, of the pecan grower in particular, where their method to measure moisture content was only accurate to 0.5. So just 0.5% for moisture content, which seems pretty good, right?
Yeah, really good compared to what I normally see.
Yeah, so you're thinking, oh, yeah, that's 0.5%. I'd be happy with that. But when we look at that relationship with moisture in the pecan, we can see that, and we have a secondary graphic that's kind of showing a plus or minus of 0.25, so half of that, right? So if we say 0.5, it could be pushing it up a little or pushing it down. What does that mean in terms of safety and mold growth? When we look at the isotherm, we'll notice that even if we just scooch it up a little bit, 0.25% increase in moisture content actually puts us in that 0.7 water activity, which is where mold can start growing. So that is a big deal. If you don't know, when you have this variability in your one measurement that you're using, when you really look at it, it's not telling you all that you need to know. For water activity, we have the granularity in that measurement is huge. And so you can see in the second graphic, we have a range of 0.01 water activity, and we can measure every little bit of that. And so it's very easy to see where we're really going to lie in the moisture content. And really, it's about water activity and not moisture content anyway, where that mold limit is going to happen, or where we're going to have some issues in that realm.
And again, I just want to point out that 0.5% I think it may not even be realistic. Most of the time I see plus or minus 1 or even 2%. But this graphic does a really good job of showing that if you're close to that microbial limit and you're only measuring moisture content, then you have a really good likelihood that some of your product is going to have issues with mold. And the way that I see some companies try to deal with this is just across the board over drying. But then you run the risk of messing with your yield and your revenue, but maybe over drying and getting to the point of lipid oxidation occurring. So I think that what we're trying to show here is that if you use water activity, that's the correct measurement. And you shouldn't just be measuring maybe the final product, but you should be measuring incoming ingredients throughout production and then also the final product. So there's a whole range of places that you should be watching how your water is changing over time.
Right, that's a really good point because even if, and we kind of talked about it before, if you have a supplier that you continue to use year after year, they're still going to have variability. It's just unavoidable. You just need to know, and then you can make adjustments to your own process. So even if you're, you have the same supplier, like I said, you're still going to get the variability. So if you're measuring as it's coming in, then you're going to know what you're getting. And water activity is just a better metric in the sense that is what's going to be driving any microbial growth. It's not moisture content and other things, moisture migration, which we will be talking about in the future. But it's an easy measurement. It's a few minute measurement, so it's faster than many moisture content methods actually.
Yeah, I think that's a perfect segue because in our next section we will talk about mixing these things together and predicting moisture migration and how that can be done with an isotherm. Yeah. Next, we're going to talk about one of the biggest challenges about fruits and nuts, and that's when you start to mix these things together and understanding which way the moisture is going to move and maybe the implications of making a mixture. So, Mary, I'm going to hand this over to you since we have talked about isotherms. How can we use these isotherms to predict what will happen when we combine the blueberries and the almonds?
Right. So a misconception is that moisture moves because of amount. So when we're talking about that, we're talking about moisture content. If something has a higher moisture content, then it's going to be the one moving the moisture, or moisture is going to be moving out of that to the other things. And it's actually not. It's not amount, it's energy level. When there's more energy, then we're going to have movement. It's physics. So if we look at our blueberries and our almonds here, and I'm going to kind of take this example where our blueberries are at a 0.48, which is a pretty decent place for blueberries, for meaning in terms of water activity, and our almonds here are 0.30, which is a pretty good place too. It avoids any rancidity, but it's kind of that nice texture that we talked about. What's going to happen is the blueberries being at higher water activity, the moisture is going to move down into or over to the almonds themselves or any other ingredient. So that's going to be the factor. Now, we could lower the water activity of our blueberries by adding what we call a humectant, which is like a sugar or a salt. I mean, there's other things, other sweeteners, and that will lower the water activity. And the reason I mention that is because if these are close to each other, we won't be having any moisture migration. So even though this could have a lot of moisture amount, a higher moisture content, if we can bring the water activity down where these are similar, we won't have any moisture moving at all. And that could be, that's a good example, I think, of that is when you look, and you mentioned earlier, was fruit in cereal, right? You have a cereal with a crispy flake, that's a low water activity, low moisture. And we have a fruit, a raisin, which obviously has a lot of moisture and can be higher water activity. How does that work? How can you have them live in the same space? That's because there's sugar generally added, and especially when you look on the outside of like a raisin, that lowers the water activity, so they're closer. So that's maybe some way to think about what we're talking about in terms of it's really the difference in water activity and not moisture content. We do have an example to kind of demonstrate what is it like to predictively model when we blend these things together, because that is a big thing. They're fine on their own, but now we're going to put them together. What are we going to get? So in our example here, we've got our two isotherms. The blueberries are in the blue trace, and then we have almonds in the orange trace, right? So we put these together, blueberries at about a 0.48 water activity, and their isotherm, which is a different shape, you'll notice, than the almonds. And the almonds came in around 0.3. So let's talk about the almonds first. And you'll notice that trace, that isotherm there is quite flat, which means that we're going to have a big difference in water activity and a small difference in moisture content. So circling back to that pecan example, if we just are able to measure moisture content and just really, a wide range of moisture content, we're going to get a ton of change in water activity. And that's not what we want. We want to know what we're getting. For the blueberries, we're going to see, for the same range of water activity, a bigger change in moisture content, right? So we can take those relationships and we can blend them together. And so when we do that, I have, in this specific example, I have picked where we have mass, twice as much blueberries as almonds, and we blended them together. And you'll notice that there's two things on this graph that I haven't discussed yet. One is the green trace, and that's the combined isotherm. So that's the combined relationship of these two together. So we can actually predict that. The other is a blue dashed line going up and down at around 0.45 water activity. And that is where the water activity is going to end up once we put these things together. Mm-hmm. So we can all know that. Just if we have the isotherms and we kind of know where everything's starting, we can predict where they're going to end up. So we don't have to actually do it yet until we know where, this is in a good range. So when we look at the final water activity, it's at 0.45. The blueberries started at 0.48. So you can definitely see here where the blueberries are the major contributor for where that water activity is going to end up. Now, the next step to do is to think, is that a good place for the blueberries? That's probably a fine place. It's already very close. Mm-hmm. Is that a good place for the almonds? That's a good question. Is this going to give us a soft almond if we put these together at this ratio? Or are these going to be, at 0.45? Is that going to be too soft for our almonds? This is something that we have a tool for, and if you want to talk about that.
Yeah, sure. This graphic that we've been looking at, it's basically derived from a graphic on the Moisture Analysis Toolkit. This is a software that we worked a lot on just this last year, kind of updating and making it really user-friendly. But basically in that software, there's a mixing ingredient tool that you can do exactly what we're looking at now. So you take an isotherm for each of the ingredients that you're adding. You have to kind of think about which way the water is going to move. So you may want an adsorption curve for your almonds and maybe a desorption curve for your blueberries. But basically you can use this tool to get the predicted final isotherm that you pointed out earlier in green. That isotherm can actually be used to predict shelf life and start to even make packaging decisions on a product or a mixture that you haven't even made yet. So you said this a little bit, but I just want to clarify that, if you have these isotherms, then you can sit at your desk and work through these mixtures, maybe think about different ratios or think about the implications of your almonds changing to a different water activity before you even go and make that product. And I work with a lot of teams that use this tool. And generally the feedback that I get is that they can release a product 4 or 5 times faster because they don't have to do all of these physical trials and wait and see if texture changes. They can start to look at these mixtures right there on their computer, and they basically make an internal library of isotherms with all the different ingredients that they work with so that they can really speed up their R&D processes. So in the toolkit, it will show you the final water activity, it will show you the isotherm, and then again it will give you the coefficients for that curve so that you can look at things like shelf life. And these are some of the things that we've touched on in the past. We have a webinar specifically on shelf life and another webinar specifically on isotherms, and I'm sure we will have those links listed below. So if those things sound helpful to you, definitely check them out. And also we're always happy to demonstrate the software and kind of walk it through with your team to show you what it may look like. So I think that's it for looking at mixing and talking about moisture migration. In our next section, we're going to talk a little bit about some of the business implications and some of the successes that we've seen with people who are using water activity and using isotherms to improve their variability and their precision.
I think this is a good place to talk about what can impact your profitability and talk about some kind of actual business cases, some things that we've encountered as we've worked with customers who work with these natural ingredients. So first I thought maybe I could talk about one of the impacts that is a major issue and needs to be considered. We've talked about the product themselves and making sure we know what we're getting, but what happens after the fact? There are other things that we haven't discussed quite yet, which is storage conditions and temperature. And the reason I want to bring those up is because generally if you're increasing a temperature, you're increasing your water activity from almost all ingredients. So let's say you produce a bar or a snack mix, and it's fine in your facility, and then it gets sent around the world, and you've got in a truck, let's say that's hot, or a shipping container. Water, the humidity and the temperature can really affect that product, and specifically temperature can increase the water activity past a point where it's going to be safe and you can start getting mold growth, where at your facility it was fine. Now that relationship of how temperature affects it is also dependent on the product itself. So it's something that you can study. You can actually find out the relationship of how temperature affects your product. But in general, just know that increasing temperature is going to increase the water activity, and to be able to account for that.
And from my own experience, a lot of times when I'm consulting with other food scientists, I think that one of the main concerns is avoiding a recall. And from what I've seen, a lot of recalls will happen because that storage temperature or a shipping temperature gets a little too high, and then the water activity reaches a threshold that we've touched on earlier in our different sections. But basically that water activity gets high enough for microorganisms to grow. And I think that this really shows the power of having an isotherm and understanding water activity, because if you have this data and you have things under control, then there's no reason that you should ever have a recall. And these things can cost millions of dollars. They can hurt a reputation. So having the right data and knowing how to use that data can help avoid any recall. The last thing that I want to focus on is just a business case scenario. This is with a client that Meter Group works with. I've shown a very similar example in the past for pet food, but I'm going to kind of use the same format today to look at a prunes producer. So we work with a prunes producer who have a really big annual production of about 30,000 tons. And their target for their prunes was 30% moisture content. So even though we're talking about moisture content, we then turn to water activity and create that isotherm curve to understand how much could we increase the moisture content while keeping the quality and the safety that they want. So by using that isotherm, we saw that they could increase by 0.5% moisture content and also reduce their variation and prevent any of their product from going above 0.7 water activity. So their new target was now 30.5%. This allowed them to increase their production, so now they have a higher yield. And because they're selling this for a price per ton of $3,250, that means in 1 year, just that small change in moisture content resulted in an annual yield increase of almost $500,000. So this is just one product, and again, just a small change in moisture content. But by changing or by looking at water activity, by understanding the isotherm, and then by implicating or introducing some controls, some environmental controls, and maybe looking at their packaging, it's really easy to make that adjustment and then to go to bed knowing that your product is going to be safe and not having to worry about a recall happening. So I think this does a really good job of showing a business case. If there's a specific product that you work with, or something that you'd like us to put a business case together for, it's really easy for us to do. We work with all types of products. We've just been focusing mainly on blueberries and almonds today because that's what we had available, and it's really easy to demonstrate the isotherms and the moisture migration and these different things that we've touched on. But again, if there's a specific dried fruit or nut, final product or ingredient that you work with, I'm sure that we've already worked with it in the past.
Right, and I just wanted to mention too, we did focus on blueberries and almonds this time just to keep it really simple. But this would expand to, the theories that we're talking about expand to everything, any kind of food product. And so if you are working with a nut butter, the things we talked about are going to be similar. They're going to be impacted in the same way. If you're using a fruit paste, like a date paste as a base for your bar, it's the same story here, right? So just wanted to know that when we're talking about these things in general, it really is a generalization in that it applies to so many things. Another thing too, we were focusing on like microbial growth and yield and everything mostly, but it could be other things too. When we first were looking at isotherms and the way that water activity impacts different reaction rates. Let's say if you're having a bar or a product that has a specific nutritional additive to it or like a nutraceutical or a functional food, it's going to apply to those as well. All these theories are going to apply to that too. And so you need to make sure that if you're making a claim like that, that you're going to be able to maintain that claim. And that's an important thing to consider as well.
Let's go ahead and turn this over now to the Q&A section. So we'll take a couple questions, and then again, if there are any extra questions, you can reach out directly to us, or we'll have some contact information here at the end so that we can make sure to answer all your questions.
This first question is, how quickly does moisture equilibrate between ingredients, and are there ways I can influence this?
I'll take that one. It can take a little bit of time. It depends on that relationship of how quickly something takes up moisture. When we did our examples of the blueberries and the almonds, it took about a week to put them at a different water activity and then let them be. But if you're looking at, most things when they're packaged aren't expected to be consumed in a week. So that is something that it will eventually, just to keep in mind, it'll eventually get there. It might be, depending on the product, faster or slower, but it all will get to be equilibrated inside that package. So you can be assured that will happen. When you have a bigger difference in water activities, that is going to be the driving force. So if you're able to get your water activities closer together, then you, number one, don't have as much moisture migration. And number two, it'll come to a good equilibration quicker. So it's always good if you can try to minimize the difference, and I definitely recommend that, to try to get your water activities to be similar. Then you won't have as big of an issue of that moisture migration in your product.
Question number 2 here. How can I use moisture content measurements to predict moisture migration?
I can take this one, and this goes back to one of our earlier sections. I think a lot of people think that they should be using moisture content because it's quantity, and maybe it makes a little bit more sense to them. But what I hope that we've shown in this webinar is that it's really the water activity that you need to keep in mind. The water activity is a measure of the energy of that water, and it dictates which way the water wants to move. Water always wants to move from a high energy state to a low energy state. So in the example that we looked at, by understanding that the water activity is higher in the blueberries, that water wants to move from the blueberry towards the almond to reach an equilibrium. So don't worry about moisture content. Focus on water activity if you were thinking about moisture migration.
All right, this next question says, if my product gets packaged at a water activity level very close to microbial limits, how much variation in temperature after packaging would allow it to get moldy?
So it's going to, you do want to stay away from that microbial limit. You don't really want to get too close. And what I mean by that is, if I had to say, and I really hesitate to say how close you can get because it really depends on the product itself. What is its relationship with temperature? Meaning, is it really impacted a lot by temperature? And that, like I said, that's something you can find out, and it is different for different products. But if I had to hedge it a bit, I would say maybe 0.1. It would definitely keep you in the safe zone. So if we have the microbial limit of like 0.7 water activity. If you're around 0.6, that's probably as close as I'd really want to get. And remember, in that water activity range, there's texture things happening too. So it's a lot to consider. But if you're focusing on microbial limits, I would recommend something like that if you were forced.
And I see the same in a lot of industries, in fruit and nuts and other products. Usually setting a water activity of 0.1 below the microbial limit is a pretty safe bet. But I will also add for this question, if you were right at 0.7, let's say right at the microbial threshold at room temperature, as soon as your product leaves your facility, if it experiences any temperature higher than the temperature that you tested at, then as soon as you go up in temperature at all, you run the risk of your water activity increasing. As soon as that happens, microorganisms can start to grow. So there's kind of a balance there between understanding the temperatures that your product may experience and then also setting a water activity low enough that you're safe if your temperature goes up, that you're still going to be below 0.7 or even 0.65.
Right. And I wanted to mention quickly, if I could, two other things. These are natural products, so most of the time they don't have a kill step. I mean, if you're roasting a nut, then, that should, if you're doing it right, I guess you could say, that it would be, killing any microbes. But for a lot of this stuff, it's things can still be on the surface of your natural food, and they won't grow if you can keep your water activity low. But if you do get high, and even higher, we're talking about molds, that's pretty low at 0.7. But if you get higher, you can run the risk, if it's in a different environment, or your packaging isn't good enough to throw your humidity high, which is a factor now. Where you can have like E. coli or salmonella start to develop, and that is much higher water activity. But just remember that those things can still survive in natural foods. They just can't thrive or grow if you can keep the water activity low. And the other thing I wanted to mention too is the impact of packaging, which I know you have a lot of experience. So if you want to discuss something concerning packaging in relation to temperature and such.
Yeah, sure. Just really briefly, if you're producing a product that is close to a microbial limit, one way to keep your product within your ideal water activity range is to consider your packaging. The lower your water vapor transmission rate for that packaging, the better you're going to be able to keep it within the range that you need it to be, even at different humidity or different temperatures. So again, we have another webinar that goes into this in much more detail, and we'd be happy to discuss packaging with you.
So I think we have time for one last question here. This last one says, is it necessary to check moisture or water activity at any stage beyond initial ingredient mixing?
Yes.
Yes, definitely.
Yes. Recommend, of course, water activity, as we've discussed, because moisture content isn't giving you the full picture to be able to avoid some of the problems that we've talked about. And then the process control, you can achieve that a lot better with water activity. And it's good to test the incoming ingredients, but post is also very valuable, because then you'll know what you've produced. Is it at the level that you are expecting? Do you have any more comments?
Yeah, I'll just say that successful companies that I see who really have control of the water in their food or their ingredients do measure at the start. They will only accept ingredients if they're within a 10% range, or they set a specific range, because that variation, keep in mind, will be carried into the final product. So I recommend measuring at the start your ingredients, measuring during production. We even have an inline solution now, so that you can always hit your target water activity. But then again, at the end, you should be measuring your final product right when you put it into packaging. And then we'll even see companies who do like a shelf life study, who will measure water activity over time. So it's definitely something you want to monitor through the entire process. And by doing that, you can avoid recalls or any of these other issues that we've talked about today.
That's going to wrap it up for us. Thank you again for joining us. We hope you enjoyed this discussion as much as we did. And thank you again for such great questions. Please consider answering the short survey that will appear after this webinar, and look for the recording of today's presentation in your email. And stay tuned for future Meter Food webinars. Have a great day.